Welcome everybody. Today we are going to learn screening test, which is very important part in epidemiology study. Let us see what is the screening test. If you want to diagnose any disease, we need to do laboratory test to identify whether somebody has the disease or not. So all the time, do you think laboratory tests are correct? Unfortunately, in many cases, laboratory test will give positive result. That does not guarantee the patient has the disease. Similarly, laboratory tests give the negative result, but actually the patient may have the disease. So both are the mistake, are error done in laboratory test. So positive test does not guarantee that is the patient has the disease. Similarly, negative test does not guarantee the patient is disease free or the patient is normal. So to detect this abnormality in the laboratory test, we must determine how the valid the test is. How we can determine the test is valid. That is done by screening tests. One of them is sensitivity, other is specificity. It is defined. What is sensitivity? What is specificity? So let us define T plus is the positive test result in a lab test. So okay, T plus, and T minus is the negative test rate in a lab test, and D plus represent the patient actually has the disease. Okay, the T plus means somebody actually is suffering from a disease. Similarly, D minus represent the disease is actually absent. That is, the patient is normal. The patient do not have the disease. That is D minus. Okay. Then sensitivity can be defined as the ability of a test to correctly identify the patient with the disease. So sensitivity is the ability of a test how correctly identify the patient has the disease. So how we can measure? Okay. So calculation of sensitivity based on how many people have the disease. Okay. So let us define details. So sensitivity is the conditional probability, that is, the test result is positive condition that the person has actually disease. So sensitivity is nothing but the conditional probability that the test result will be positive given that the person has actually disease. This is the sensitivity. Let us define more accurately. So sensitivity is the probability of being positive test have the disease. So we can define sensitivity, positive test result condition the patient is the disease is present. Okay. Now let us, as you denote the notation, in terms of notation, let us define. So sensitivity is the positive test result condition the patient has actually the disease. That is, somebody have the actually disease and will get the positive. What is the probability? This is the sensitivity. So we know that from conditional probability A given B, probability A and B divided by probability B. So we can write the T plus is the positive test result and D plus is the patient has the actual disease. So we can write probability positive test result and the disease is present divided by probability the disease is present. So in this way we can calculate from the conditional probability sensitivity. Let us see other thing that is called specificity. Okay, let us define specificity. So we can also, and we can denote it by intersection we can denote it by for the and. Let us define what is specificity. So specificity also the ability of the test, how correctly can define the person is free of the disease. So this is the ability of a test that will declare the person actually have no disease. Okay, this is the ability of the test. From the specificity, you can know how correct the test that is correctly identify the patient do not have the disease. So as we define, a specificity is based on the number of people suffering from the disease, and alternatively specificity, sensitivity defined on the number of patients suffering from the disease, and specificity based on they do not have suffering from the disease, that is they have the normal life, they are not sick, so they have no disease. So specificity is based on somebody is not suffering from the disease. How we can calculate? This is also conditional probability, that is the test will give negative result condition that the person does not have the disease. That is specificity, nothing but the conditional probability. The test will give a negative test result given that the individual is not suffering from the disease. So let us define by conditional probability. If we define, so this is nothing but the probability of being negative test when the disease is absent. So as we define by the notation, how can we define? So this is the nothing but the negative test result condition the patient or the person do not have the disease. So we know from the condition law that is A condition B, that is negative test result and the disease is absent, that is somebody is not suffering from the disease, probability the disease is absent. So what is the probability? The patient is not suffering from the disease. So we learn that specificity is the conditional probability that the test will give positive test result condition the person is actually is suffering from the disease, and alternatively specificity that the test will give negative test result condition the person is not suffering from the disease. So this is the sensitivity and specificity, two most important terms used in epidemiology. So you need to do more practice to know or understand sensitivity and specificity. We need to know some other terms also. Okay, and when you will define that, this will be more easier. Let us go. So there is a one test that is called gold standard test or gold standard. How we can understand from the laboratory test, we can understand somebody have disease, but that is he or she doesn't have the disease, or somebody declared in the laboratory test that the patient is normal, but actually the patient has the disease. How we can know? So there is a gold standard. Gold standard is nothing but the screening test, a single test or maybe the combination of tests that is considered the correct preferred method of diagnosing a particular disease. That is the still now gold standard is a screening test that is the perfectly identify where perfectly identify the disease is present or disease is absent. So then we can compare how correctly that the patient is suffering from the disease or do not suffering from the disease. That is, we know specificity and sensitivity. So gold standard test, we have to compare with the diagnostic test in a laboratory with the gold standard. Somebody is suffering from the disease, if it is a identify laboratory test, then you can do the gold standard test, then you can identify whether the patient have actually disease or not. This is the gold standard test all over the world. A researcher use this or clinical trial also use this. Okay, let us go in details to understand the other terms in epidemiology. We have to use a validity test that is called confusion matrix. Is a 2x2 confusion matrix. Okay, so if you see the upward is a gold standard test. Somebody say disease present, found in gold standard test disease present, and it is found disease absent. And this is the column, first column, that is test result, that's laboratory test, found that the test is positive, that is declare the individual is suffering from the disease, and negative, that is individual is not suffering from the disease. So this is the 2x2 contingency table. This is also called confusion matrix. From confusion matrix we can define many things. Okay, so there is a inside four cell. Okay, there is inside 4 cell A, B, C, D. This 4 cell is a combination of this gold standard and laboratory test. This is the N intersection. Okay, so this is the intersection. So let us define. There is a medical terminology or epidemiological terminology that you should know. Who want to study biostatistics or more advanced level, they should know this confusion matrix to understand the specificity and sensitivity. Okay, the cell A is denoted by, that is cell A is known as true positive. That is the patient had the disease also declared by the gold standard test and also found in the laboratory test. So this is correctly identify somebody have the disease in a laboratory test. So this is N. Okay, somebody also identify a positive test in the test result, also positive in the gold standard test, that is denoted by A, that is called true positive. Okay, that is truly positive, somebody have the disease truly identified by the laboratory test. Okay, that is called true positive. And the cell B, that is false positive, that is the laboratory test, the test result found that the patient have the disease, but actually it is found by gold standard test the patient do not have the disease. That is called false positive. Okay, they falsely identify the patient have the disease, but actually the patient do not have the disease. This is called false positive, and we call it is denoted in the cell B. And cell C, that this is the negative test result in the laboratory test, but actually the patient has the disease. So this is called false negative. Why false negative? Because that is the laboratory identify the patient does not have the disease, but it is found in the gold standard test the patient has the disease. So this is called false negative, and in the cell C it is Fn. Okay, and the true negative. Okay, this is the true value, that is laboratory test found the patient does not have the disease, also it is found in the gold standards on the disease. Correctly identify somebody do not have the disease, who actually is not suffering from the disease. This is correct. So A and D is the correct one. A is the positive correct test result by laboratory test, and D is the negative test result by laboratory test. So A and D is the correct result. B and C incorrect, wrong answer, error. This is called false positive and false negative. So if you sum up the positive result, true positive, false positive, you will get the total test positive in the laboratory, and similarly negative, total test negative in the row, negative in the laboratory test, and in the column, if you consider the column, that is the gold standard test, somebody actually have the disease by gold standard test, that is total disease, and total normal, that is disease absent, there is no disease, the patient is normal, total normal, B plus D. So these are the four intersection part in the confusion matrix. Now it is very easy to define specificity, sensitivity, and some other terms. Okay, let us go in details. Please do practice several times, otherwise you cannot memorize. Put this confusion table in front of you and do the practice. It will be more easier. Okay, do practice. You need more practice, otherwise you cannot memorize. Just take the confusion matrix, what is the result of the test, and what is the actual condition of the patient, whether the patient is has the disease or not. So then you can find this confusion matrix, then you can do what is true positive, false positive, false positive, negative, true negative. Okay, you can get it. Okay.